Chairman, IEI Salem Local Center, and National Council Member, IEI, to welcome the guest and the gathering. Please, sir.
Thank you, sir. So we are அனைவருக்கும் தமிழ் புத்தாண்டு நல்வாழ்த்துக்கள். On behalf of Institution of Engineers, Salem Local Center, we are very happy to welcome today's two chief guests, one from academic, one from the industry. So this is Kavita, the senior lecturer. Welcome, madam. Senior lecturer in Department of Electrical Electronics Engineering, Tyagaraja Polytechnic, having more than 20 years of experience. With her vast experience, I think she can able to deliver today's talk on the Industry 4.0 and the PLC fundamentals, and madam is involving and teaching and having the practical experience also. I hope, madam, this is a common forum. Hope you can understand this, and you can explain what is Industry 4.0 and the PLC fundamentals for the benefit of all the engineers joined for this meeting as well as for the students. The same manner, Engineer Karthikeyan, working in Ashok Leyland as a senior manager and having the vast experience in the supply chain domain. Also, he is a certified Six Sigma Green Belt engineer, and I think after completion of his course, he has joined the Ashok Leyland. He is continuing there. Isn't it? Welcome, Mr. Karthikeyan also. I think he will be joining after Mrs. Kavita lectures. So I am happy to welcome both of them, and also the members present here, executive committee members, Viola madam, Davamani madam, and our immediate past chairman, Angaraj, and other senior members and student members, those who have joined here. So we are organizing two lecture program consecutively in two different areas, one in the electrical field and one in the mechanical engineering field, so that the more knowledge will transfer to our members. So on this occasion, I am very happy to welcome you all, and I thank Engineer INR for fixing the today's two guests, and I also thank the two guest speakers for accepting our invitation in a very short period and delivering the lectures for the benefit of our members. So thank you, INR. So I also thank all this event seminar managing committee members, the top committee members, for their valuable work. I once again welcome you all for the two consecutive seminar of 128 and 129 Engineers Talk Forum organized by the Institution of Engineers, Salem Local Center. Welcome you all. Now I request Engineer Arun to introduce Engineer Kavita, and after her lecture, you can introduce Engineer Karthikeyan.
Sure, sir. Sure, sir. Sure. Thank you. Thank you very much. And now it's my pleasure and privilege to introduce the chief guest and keynote speaker of today, Engineer G. Kavita, Senior Lecturer, Tyagaraja Polytechnic, Salem. She has completed a master's degree holder in electrical and electronics engineering and currently doing PhD research. She has nearly 20 plus years of experience in industry and teaching. She is expertised in PLC programming, softwares like TIAC programming and Prophecy, and she is also expertise in ladder diagram designs, industrial control circuits, and SCADA systems, AI applications, and electric vehicle charging stations. She has published nearly 12 international papers in journals and conferences, and she has attended nearly 22 faculty development programs. She has organized seminars and applied for 3 patents. With these words of introduction, I would like to invite Engineer Giavita to present on the topic Industry 4.0 and PLC fundamentals. Over to Engineer Kavita, ma'am. Please, ma'am.
Thank you, sir. Thank you, sir. Thank you for the welcome, sir. Sir, whether this screen is visible, sir? Sir, whether the screen is visible, sir? Hello, I am
Yes,
audible.
madam. Yes, madam. Yeah, you are audible. Screen is visible. Please go ahead.
Okay, sir. Okay. Good evening to one and all present in this great section. Respected chairman, respected honorary secretary, respected committee member, and respected subcommittee member of IEI, fellow faculty, and dear participants. I am Kavita, lecturer in electrical electronics engineer from Tyagaraja Polytechnic College, Salem. It's my pleasure to present in this 128th webinar series on the topic of Industry 4.0 and PLC fundamentals. In today's section, we'll explore how the modern industries are transforming through the digital technologies and how programmable logic controllers known as a PLC and plays a vital role in the industrial automation. This industrial automation we have been going to be present today is Industry 4.0. How the Industry 4.0 has been evolved from the Industry 1.0, 2.0, 3.0, and 4.0. From the Industry 1.0, only the steam power and the mechanism has been evolved in this area. In the Industry 2.0, there is a mass production of assembly lines. Here, the electricity has been make as a revolution in the Industry 2.0, and the Industry 3.0, computer and the automation has been placed in this third revolutions, and the fourth revolution, that is a cyber physical security, has been placed here. Here, the digital transformation is placed in the Industry 4.0. Now we are in the fourth era of the industrial automation. Let us see what is Industry 4.0. It is a fourth industrial evolution where modern industries or advanced digital technologies to create, we can able to make it as a smart, automated, and interconnected system. This integration of digital technologies in industries, this Industry 4.0 combines the technologies such as Internet of Things, artificial intelligence, big data analytics, and cloud computing. Even it can able to interact with the machines, sensors, and systems which are all being digitally connected. The data is continuously collected and monitored and make a better decision making with this one Industry 4.0. Instead of working in independent machines, now communicate and share the data to improve the efficiency and performance. Industry 4.0 is placed in everywhere in all the factories. Even in the small factories with the automation and the data exchange, nowadays the factories becomes a very small because machine can monitor themselves. It can able to make the decisions automatically. For the real-time data, it can exchange the data between the machines, control system, as well as the operators. Why we are going for the automation? This automation is nothing but we have been reducing the manual human actions. It can act as a intelligent system. It can able to control as well as it can able to give the consistency as well as the productivity, mass production we can able to get through this with a high quality of manufacturing environment. This automation improves the safety as well as the production. It can able to reduce the operation cost. So we are going for the automation. There are two types of automation. One is the analog and as well as the discrete. In the discrete, it has been classified as the analog and the digital. Even the motion control as well as the robotic also comes under the automation types. The layers what we made for the automation is nothing but we can able to get the data from the field devices, from the PLC, and if we can able to interact with the SCADA through the ERP enterprises. The application of this industrial automation we can able to use for the packaging, textile industries, wherever we want to make it is an automation in the assembly line, we can able to use this industrial 4.0. So everywhere we are in the fourth revolution, that is the industry 4.0. Everywhere in industry, we are using the automation of this one to get the smart as well as to get the more production with a high quality of and with the consistency in this one. Then why we have been concentrating on the PLC? PLC is nothing but is a programmable logic controller. It is an industrial digital computer. It has been adapted for controlling the manufacturing process, such as assembly lines or robotic devices. Because it has been designed for the high reliability, we can able to programming with very easy manner, and we can able to detect the fault also. We can able to clear the fault within a fraction of a second by instead of using the manual system. This evaluation is originated in the year of 1968 with Modicon 84. He has been replacing the hardware mechanical relays to the programmable logic control without the rewiring, and we can able to configure each and every time. Instead of using the manual time, we can be able to reduce the time by using these PLCs. The PLC core components we have been using, whatever the computers as the component, the same component has been used for the PLC also. One is the input, memory, and as well as the output. In the input, we are using the sensors, push button, switches, digital or analog switches. Even the signals we can able to use as an input for these PLCs. Whenever the input has been get from the PLCs, automatically passes to the memory, the brain automatically executes the inputs. It reads the input and executes the logic and gives the output to the output devices. The output devices, it may be actuator or relays or motors or starters. Whatever the output we have to control, all this we can able to control through this PLC system. The main power supply for this PLCs needs only the 24-volt DC supply. There are standard languages we have been used for programming to the PLCs. One is a ladder logic diagram, functional block diagram, and structured text programming also we can able to do with this one. Nowadays, industries has been choosing the Siemens PLC. Why industries has been choosing the Siemens means? Because it has a automatic sector, it has a TIA portal that is a totally integrated automation. It has an engineering framework. It can able to integrate PLC, that is a human machine interface, and it can able to integrate the any other control devices. It has a two types. One is a S71200 and S71500. Both are in the same. This one, S indicates the Siemens because 1200 is used for the small and medium purposes. For 1500, you can able to use for the large scale industries. Both the Siemens we can able to use this one because we are using the Siemens. It is used only for the scalability. We can able to diagnostic the problems, and we can able to connect it to the industrial IoT connectivity through the Profinet or Ethernet connection. We can able to do this one. There are various types of PLC brands are being available. One is a Siemens, Allen Bradley, Schneider, Electric, and Mitsubishi, Omron. These are the various PLC brands. Whenever we want to buy the PLC, the selection factors are to be considered. The selection factors are hardware reliability. It should be support with the ecosystem, then the normal environment system, and communication standards. That communication standards, either we can able to communicate through the Ethernet or Profinet or through the IP address also we can able to communicate, as well as the total cost of the PLC. These are the factors while we have to be considered for purchasing the PLC. Then again, one more, this one we have to be concentrated on the scalability and the safety. The PLC has to be as the ability to expand the IO integrate, that is a each and every this one, you can able to integrate more input devices, more output devices. Whenever we want to enlarge our application, we can able to integrate. Otherwise, if our application is less, means we can able to remove the integrated devices also. Then safety integrated levels should be there, and cyber security applications also should be available in the Siemens PLC. In the Siemens A71200, what is the special features of this one? It has a scalable hardware. That means it has a CPU in the range of 1211C to the 1217C. That is, that much of CPU is being available in this Siemens A71200. Each and every CPU you can able to use for any other applications. It has an onboard of IO modular expansion through the signal boards, as well as it has the signal models and communication modules being available in the Siemens S71200 in the hardware configuration. In the technology functions, when we are considered for the technology function, it has a high-speed counters, even the pulse width modulation, as well as the pulse train output and PID loops for the process control. It has been occupied in the Siemens S71200. For connectivity, it has a Profinet interface. Even you can able to integrate with the HMI and distributed IO supports. Even you can able to integrate with the IP address with the web server services also. It can be integrated through the connectivity. And the diagnosis and security, it has a very much secure this one. What are the programs you are going to do? You can able to make it as a password, and you can able to set this one. Most security this one, we can't able to dispose to some other else. If suppose we want to remove the security also, it has been possible this one. If there is any fault, means we can able to identify the fault and we can able to solve very easily when compared to the normal hardware system. This is the features has been occupied in the Siemens S71200. This is the picture of Siemens of PLC. In the Siemens PLC, we have to use a software is a TIA portal, that is a totally integrated automation. From the name itself, all these models has been integrated in a single environment. So it is called as a totally integrated automation. It can able to integrate HMI, PLC, as well as a drive configuration in a single interface. It can able to streamless for the entire project life cycle for planning to operation. We can able to communicate. For suppose you want to control only one device, means you can able to connect it to the only one device. Suppose you want to connect more and more devices, means you can able to integrate more number of models, as well as for the input also, as well as for the output model also. You can able to integrate through this TIA portal. We can able to integrate all these devices. This is a picture has been given in the side. This one, the small picture has been showed as a model. Each and every model you can able to integrate with the PLC. This one. In the TIA portal, there are so many libraries as well. More number of libraries we can able to access. In what manner we want to program this one, all this we can able to access. There is a counters, timers, input and output devices. What are the devices you want to do this one? Suppose you want to make us a tag, you can able to design the tag also. For suppose you want to make it for the hardware this one. Suppose you want to control the motor. Instead of seeing the live this one, you can able to set it in the simulation also. You can able to run in the simulation. If the simulation controls the output, if the output is come, means you can able to connect to the hardware also. That all this provision is being available in this totally integrated automation software. Even it has the security, how to protect, way to protect all these features has been available in this TIA portal. These are the connectivity we have been used for the TIA portal. One is a HMI, that is a human interface, industrial IoT, even the node read, all this we can able to integrate with PLCs. In the human machine, why all this interface has been connected means it can able to bridge the gap between the floor operation to the cloud analytics through the advanced integration. With the HMI, it can able to provide the robust visualization, that is a real-time alarms. We can able to control for the management operators. In the IIoT, that is the industrial IoT connectivity, it enables a seamless data exchange through the protocols, through the IP address also. You can able to transfer the data from one place to any other place through the cloud connectivity. Even the node read program, we can able to do this one. Even you can able to use this. It is a simple product programming. All this been available in the non-Moodle program also. This node read program has been established in the non-Moodle program itself. For the secure architecture, it can implement the segmentation for making the management should be in a very secure this one. All this will be available in this TIA portal itself. Now the future all been moved to the automation, because our successful career starts with the mastering the fundamental of logic and hardware by combining, because we are in the hardware in the core department, by combining the core PLC knowledge with the modern industrial IoT skills. All the students can able to reach to the high demand opportunities in the smart manufacturing as well as to reach the global supply chains. The key roles when you have been learned the PLCs means these are the key roles you can able to place automatically, like a PLC or SCADA engineer or commissioning specialist and industrial IoT solutions architect. You can able to make it as a key role for this one. Before this, we have to know the essential skills to move to this one. The essential skills, we have to know the electrical standards and the safety protocols, what we have to do and where we have to do, or if the standards which we want to we learn means we can able to move all these key roles of this one. This is a modern tool set has been available in the Siemens. One is a TIA portal and density unified and node rate for edge computing is being available in the tool set is being available in the TIA portal. The key takeaways of this section is Industry 4.0. It shifts the traditional manufacturing system towards the digital transformation through the data-centric, connected, and which has been driven by the IIoT, artificial intelligence, big data analytics, and even through the cloud computing, you can able to transfer the data. The automation backbone is nothing but a PLC Siemens S71200, because it has been a reliable. It is for the real-time industrial control. It has been used in everywhere industries. It occupies the TIA portal, that is a unified engineering, that is totally integrated automation by integrating the PLCs, HMI, and even any other devices in a single environment. All this being provision has been made in the Siemens S71200. By learning this one, you can able to apply it in your future skills like SCADA engineer or communication engineer, or through the solving any other problems related to this industrial automation. Before going this one, let us see how the PLC has been configured. The same this one, what normal personal computers has been the components is input, output, as well as for the CPU. The same concept has been used for the PLC also. For input interface, topmost block for connecting to the sensor input devices, that is analog and digital inputs, we can able to connect to this input interface. From the output interface, that output interface we can able to connect to the motor starters or relays, or even the lamp, we can able to connect this output interface. All this communication will be done through the Ethernet or through the any other devices. Even the IP address you can able to communicate through this one. All this controller will be done in the CPU. The power supply has been connected to this, the middle port of this PLC. This is the major component of the PLC. One is the input. The programming devices, what we have been using for the Siemens S71200 is a TIA, that is a totally integrated automation. From this total integration automation software, we are using the ladder logic diagram. All this diagram has been stored in the memory. You can able to control the output devices. This is the major components of the PLC. How it has been executed means it reads the input and sort the logic and executes the output. The same concept we have been using for the PLC. What the normal computer has done, the same concept has been used for the programming logic controller also. How the PLC, suppose if you have been switch on, when we want to turn on the motor, what we have to do? We have to switch on the switch. That switches has been going to the PLC. From the PLC is going to the motor. The same how the motor has rotates in the clockwise direction or anti-clockwise direction, that control has been made by the PLC. Through in the PLC, we are using the programming, that is with the TIA portal. The various programming languages for the PLC, not only the ladder diagram, you can able to do the programming in the instruction list, structured text, ladder logic diagram, functional block diagram, and the sequential functional chart. These are the various programming languages for the PLC. Let us see what it happens in the ladder logic diagram. Nowadays, we are using the graphical pictorial representation that is called as a ladder logic diagram. Only the three symbols we have been using. One is a normally open contact, one is a normally closed contact, and other one is the output. Whenever we want to turn on the switch, Before this, the closed switch, that is NO means normally open. Always the stop button should be in the closed condition. So it has been shown as a normally closed. Whenever we want to press the start button, before you, if you have been pressing the start button, the switch should be open. Isn't you know? The same this one, there is a normally open contact for the start button. For stop button, we are using the normally closed this one. Whenever you want to run the motor or any other output devices, the symbol has been used as a latch coil. These are the symbols. Only the three symbols is used for the ladder logic diagram to control any other applications. Even in the industries also, these three symbols has been used for many applications. The next programming language is an instruction list. The instruction list is nothing but is an assembly language. Normally, assembly language, we are using the microprocessor and the microcontroller kit. The normal, before this one, how we are going to load the data, how you can able to run the data, how to start the data, how to multiply the data, how to add the data. These are the languages. This is an assembly set of languages is being introduced in the instruction list also. This language also you can able to run the PLC. Next, this one is a functional block diagram. This is also one of the programming languages. Each and every function represents the one executable code. Whenever the function is activated, whenever the input is given to the functional block, all this operation has been done, then that output has been controlled through any other devices. You can able to control the output 1, 2, or 3. How many devices you can able to connect it to the output? All these devices we can able to connect it. It's represented in the rectangular elements only for the functional block diagram. This is also one of the programming languages for the PLC. Next, this one is a structured text. In the structured text is normally we are using the Python programming or C programming also we can able to do this one. It is a readable text, this one. From this language also you can able to work with the PLC. The same this one. If you have been pressing the start, that is PB is the push button. Whenever you have been pressing the start button, what the process has to do, that condition is been, if the condition is been satisfied, the output will be enabled through this one. By using this structured text programming also, we can able to work with the PLC. Then sequential function chart. This sequential function chart has been defined in a single location. It should be work according to the sequential manner, not in the random manner. So each and every text should be in a sequential structured text only. We have to be represented in this sequential functional chart. This is a diagram has been shown for the sequential functional chart. Then PLC manufacturing industries. There are so many manufacturing industries for the PLCs. Nowadays, Siemens has been used for the industrial. Most of the industries has been used for the Siemens itself. Some PLC brands has been available. That is the manufacturing sectors for the Allen Bradley, ABB, Omron, and Techno. These are the various PLC industries has been manufacturing for the PLC. For each and every brand of PLCs, the particular software has to be done with this one. For Allen Bradley, we have to use the software as RS Logic 500. For the Siemens, we have to use the TIA, that is a totally integrated automation. Omron, we have to use the Gen support software, and Delta or WPL software has to be used for this various brands of PLC programming. This is the various PLC applications. The PLC application is used for the many industries, even for the food packaging, textile industries, even for the printing industries, even for the travel industries, for the conveyor and all. This PLC application has been used. Even in the malls also, they have been used for the PLC. The advantages of PLC is we can able to reduce the human this one. We can able to do the programming very easily this one. We can able to increase the productivity with the quality and high consistency. So we have been concentrating on the PLCs. For doing the PLC, we are using the software is the Siemens PLC. From the Siemens PLC software, we have been used for the TIA, that is a totally integrated automation. All these small models has been combined in a single framework. From the single framework, you can able to do entire applications. Okay, thank you. Is there any queries for this one or any more doubts?
Okay, Pasavi, in case if there is no queries, let us pass on to the next seminar. Thank you, ma'am, for your
Okay.
Thank you,
presentation.
Kavita. Thank you, Kavita. Your voice is very sweet and also excellent. Thank you very much for wearing your song.
Okay,
Armo,
thank
sir.
Okay.
Yes, sir. Yes, sir. Thank you,
Thank you,
ma'am.
sir.
Your
Thank you, sir.
presentation
Thank you.
proved on Industry 4.0 and PLC fundamentals. Thank you very much.
Okay. Thank you,
And
sir.
now it's my pleasure to introduce the chief guest and keynote speaker of 129th webinar, Engineer P. Karthikeyan, sir. Engineer Karthikeyan Pondarangan is an assistant manager in the supply chain domain at Ashok Leyland with extensive experience in warehouse management, inventory control, and in-house logistics in the automobile sector. He is certified as a Six Sigma Green Belt and has handled large-scale inventory operations involving over 13,000 chases related parts with an average inventory value of around 95 crore, ensuring lean system-driven inventory methods such as Kanban, JAS, and JIT. He is also a strong practitioner in SAP, MM, and PP modules, provides internal training on daily management, inventory control, and SKD packings, and has contributed to award-winning projects on digitalization, robotics, and automation in supply chain operations. With these words of introduction, I would like to invite Engineer P. Karthikeyan to present on the topic inventory management. Over to Karthikeyan, sir, please.
Sir, good evening, sir. Good evening, all. It's my pleasure to share the inventory management to our students and staffs. Sir, can I share the screen, sir? Hope my screen is visible. I'm audible, sir.
Yes, sir.
Yes, sir. So, good evening, one and all. First, I'll introduce myself. Myself, Karthikeyan. I'm currently working in Ashok Leyland as assistant manager in supply chain management, and I'm taking care of inbound and outbound logistics and taking over warehouse management and ensuring process adherence and all these things in the material management. I'm passed out student of TPT in 2016 to 19 batch. So this is our overview of Ashok Leyland. Ashok Leyland is one of the part of Anzija Group, and we are the second largest manufacturer of commercial vehicles in India, and the fourth largest manufacturer of buses in the world, and the 90th largest manufacturer in trucks in the globally. And we have 7 manufacturing plants in all around India, and bus manufacturing plant at UK, United Arab Emirates. And in Hosur Unit 2, we particularly produce M&HCV and LCV defense range of products. In that, we have VCommet, G45 N-Truck, U-Truck, and G45 FES, various kind of models. As currently, I am working in M&HCV stores, so our scope of activity is to receive the parts, storing the parts, and feeding the parts to various production assemblies to achieve the deliverables. So basically, we will be learning in our college or everywhere the technical side of the vehicles and all these things. But it is equally important that we have to know about our inventory and receiving, how to handle the parts, how to store the parts. Since we receive various kind of parts, almost 700 parts average we are using to produce a vehicle with volumetric and all criticality of parts, wirings, ECUs, kind of things. In each of the parts, we have to store in different kind of areas and storage methods. So it is one of the toughest area to handle, which we may not be knowing in our college levels. Maybe when you come to industry, this is one of the important area to learn. So about this session, this is one brief inventory management session, and this is not a training session. Will be a knowledge sharing. This is includes and with the AL Ashok Leyland inventory management system. So what is inventory? These are the contents we are going to cover in this. What is the inventory? Types of materials and types of inventory, categories of inventory, and why inventory management is required in industry, and how materials flowing in Ashok Leyland particularly, and background behind the inventory, how we are managing in Ashok Leyland. So what is inventory? The term inventory refers to materials including raw BOF, BOF is bought out, finished, and work in progress, etc., used for production, as well as goods produced that are available for sale, which includes of complete produced vehicle also. It comes under the inventory of in any industry. ஸோ தமிழ் ஒரு வணிகத்திடம் இருக்கும் மூலப்பொருட்கள் அல்லது விற்பனை பொருட்களின் விவரப்பட்டியல் ஆகும். This inventory is directly linked to balance sheet of every company. So which is used to know the profit and loss analysis, which is this inventory also one of the part. So there are 35 types of materials available in our Ashok Leyland company. Some of the major categories we regularly use are administrative items, bought out, finished, bought out, produced, consumer of things. Those has been listed here. Bought out, finished, that is completely finished, which is having application of doing some activity in the vehicle. Imported parts, basically some of the critical parts like sensor and copper related items, all these things, it comes under imported parts. Consumables is gloves, as I told, gloves, diesel, and other things. So some of the examples I'm showing here. So bought out, finished is like radiators. Radiators is having a cooling application in the vehicle. The exhaust systems, so which is eats exhaust after treatment system. After BS6 introduction, this is one of the major role playing in vehicles. And draglings, this is the steering control, one part of a steering control mechanism. Imported parts like clutch discs, which is part of engine material, and cab tilt cylinder. This is shock absorber and cabin lifting purposes. So these are the imported parts which we are handling in Ashok Leyland. And consumables, as I told, gloves, diesel, and paintings, and uh, other personal protective equipments. All these things comes under the consumables. Types of inventory. So basically we are having three types of inventory in our manufacturing. So one is raw material, unprocessed materials used for various products like wood, metal, coal, and sheet metal components like coils, all these things. Work in progress, partially finished, but complete the product not produced, which are in basically in the assemblies, whatever materials in the assemblies which is ready to come out as a finished part. Up to that, we will consider that as a work in progress material. That is also to be accounted in our inventory management. And finished goods, once the part is ready, which is ready to sold, is called as finished goods. These three things may it's mostly related to all kind of industries. And raw materials, as I told, unprocessed metal used for various products, which is மூலப்பொருள் என்பது சில செயற்கை பொருட்களை உருவாக்க தேவையான அடிப்படை பொருட்களாகும். And work in progress, மூலப்பொருட்களை ஒன்றிணைத்து இறுதிப் பொருட்களை செய்யும் பணி, which is under progress. இறுதிப் பொருட்கள் உற்பத்தி முடிந்து விற்பனைக்கு தயாராக இருக்கும் பொருட்கள். So for an easy understanding, I've made this how to make this tomato chutney, which is raw material is for us in this process, it's tomato. On work in progress, we have to cut and do the preparatory works for all this, and up to this mixing all these things, it will be considered in the work in progress. Finally, once the chutney is made, that is called as a finished goods that we can sell or eat. All for an easy understanding, been given this. So categories of inventory in Ashok Leyland. One is moving inventory. Not only in Ashok Leyland, in every system, every industries, it should have three type of categories of inventory. The terms may be vary, but in Ashok Leyland we call it as moving inventory and slow moving inventory and non-moving inventory. Moving inventory, which is called parts having regular consumption on day-to-day basis. The parts which consumes on every day in a higher amount of consumption, that will be called as that is being called as moving inventory. Slow moving inventory, it's like order basis. Some of the materials we used to procure on order basis, like for defense material. Defense we produce based on the tenders or orders only. So that we call it as slow moving inventory. And non-moving inventory, parts not moving more than 1 year. So part which we procured, but we are not using more than 1 year due to maybe various reasons of plan cut or some order cut, order cancellation, all these things. We will call it as a non-moving inventory. Accordingly, the storage system of this materials also will be as per this category wise. Moving inventories will be in the accessible area, and slow moving inventories will be stored in the middle of the racks, and non-moving will be in the top of the rack or not from the regular location. So this is how we used to store materials for our easy day-to-day operations. So why inventory management is required? உற்பத்தி செலவுகளை கட்டுப்படுத்த உதவுகிறது. When we are holding the inventory, it directly impacts the 11% of the overall material cost. So for that we need to pay tax and all this regulatory acts. So if we manage inventory better, we can able to manage the cost aspect easily. And எந்த ஒரு பொருட்களையும் எந்த நேரத்திலும் எவ்வளவு வாங்க வேண்டும் என்பதை தீர்மானிக்க உதவுகிறது. So not only in the industries, even in our houses also, if we know how much inventory we have, we could able to easily plan what else we need to buy, how much we have to buy. All these things we can know. The same will be applicable for the industries also according to the norms. It's supposed to manage the supply chain properly, which is backbone of the business. For every companies, if the supply chain works properly, that will be the biggest factor for output. If part not comes as per planning, it will stop the entire line and it will directly affect the output and also delivering to the customers. Delivery failure will happen. So this is why inventory management is required. If we not manage the inventory properly, so these are the backlogs. We may end up delivery delay of orders and customer dissatisfaction, which is no company will not allow for that, and increased transportation costs for arranging parts. If we fail to ensure the parts on time, we forced to get the materials through air freight or some other urgency mode, which is unnecessary cost to the company, and it will increase the transportation cost. Profit loss to the organization. As I told, this will directly impact the balance sheet of the company. So now how Ashok material is flowing in Ashok Leyland. So I'm just briefing this. So this is our quantum of suppliers. We are almost having 429 suppliers in all over India. Apart from this, we are getting parts from imports. So material flow is in Ashok Leyland. Every month twice production planning meeting happens based on the forecast volume. Production planning meeting will happen. With that, 1 month rolling plan will be released to all plant peoples and suppliers. In that, current plus 3 weeks firm plan PTS list by master production scheduler. There is one department called production scheduler. they used to give the firm plan to all the stakeholders. The same will be uploaded in the SAP. SAP is System Application and Process, which is a key tool to ensure all activities right from the materials, inwarding to vehicle selling, finance, and HR related activities. All this will be handled in through SAP. Schedule flows to the suppliers based on BOMS bill of material. Based on the bill of material and number of quantities, the schedule will flow to the supplier and supply of the parts to concerned unit by the suppliers. So this is the rolling plan, and this I am attaching this bill of materials, how this will be in the SAP. So this is stock requirement list. So if we enter the each part will have the unique part code. If we enter the part in SAP, what is that the complete entire master data will appear in the SAP. There is uh, there is thing called the T code, that is transaction code. Each transaction code will have a different application. For this material management, we have plenty of codes in that. I'm showing this requirement list. If we give the indent to the supplier, when supplier can give the material. So PDT is planned deliver time. If I give today, he could able to deliver the parts in next 6 days. That is how it should be.
இப்படிலாம் வைக்க மாட்டா, அதனால அவன் தான் வச்சாகணும் வேற இல்ல.
So parts receipt and feeding. So once the part is received from the supplier, we need to appropriately account the materials even one numbers, since we are paying to supplier for each and every numbers. That has to be properly accounted, checked, and it should be received. So based on the shipment notice, gate entry will happen. Accordingly, checking methodology follows. After that, goods receipt note will be happening. Based on that only, we are paying to the suppliers. Once the part is received, we used to bin the parts storage. We used to store the parts according to the assigned location. So once this is done, this all three processes has to be done precisely. After that, we are serving parts to the two different commodities. One is to our production lines, and another one is to transfer of parts to the spares. If any vehicle is breakdown or it is in vehicle on road condition, so for that we need to support from our plant. So this is our parts receipt and feeding process flow. So there are different type of accounting methodology in various industries. Earlier, we used to have part receipt, GR, and preparation. It will be accounted in our store stock, and once we are feeding to line, we used to post manually, and it will be the stock will be whatever quantity we are posting, that will be moved to the WAP, work in progress stock. After production of the vehicle, production will do the production confirmation. It will be relieved from the SAP stock. So this is how we used to have a system earlier. Currently, so to eliminate non-value added activities, so we are following a single store concept, which is unique to some particular industries. The up to line feeding, the same concept follows. Instead of store posting and WP stock handling, directly the line feeding and this by bill of material was linked to the production confirmation. We need to position the part as per the plan. Once the production vehicle produced, production confirmation is done, automatically stock will be relieved from the system. This is how we are following currently is a accounting concept. So each and every parts is having based on the value of material. We are categorized in A, B, C, and D category of parts. D category. A is more than 10,000 rupees part, which is having more than 10,000 rupees. It's called as A category. B category of parts, double line to 2,500, and C 2499 to 1500 rupees. D category is 1499 to 40 rupees. And one more part less than 40 rupees parts which is called as bulk parts, like these fasteners, straps, and parts which is bought in which is we are buying in bulk quantities, very less amount, that we are handling, that we are calling as a bulk part numbers. So A, B, C, D, all these parts classified as X1, and bulk part less than 40 rupees parts will be called as bulk. So in that, X1 parts will be invading based on the production plan, and bulk parts will be invading based on a reorder level, which is nothing but theory of constraint, part of theory of constraint. So there are plenty of challenges in this warehouse management system. These can be avoided by implementing some of the automated solution that has been shown here. So there are this much of automated solutions are available. So we are progressing into this. So thank you. If you have any queries, you may ask, sir.
Thank you, Karthikeyan. This is Loganathan.
Yes, sir.
It's really a wonderful thing. It's a new thing for us. Other than mechanical engineer, it's a new thing
Yes,
for
sir.
managing a huge quantity of materials. So you have narrated very
Yes, sir.
simply and with all the diagrams. Thank you very
Yes, sir.
much.
Thank
You
you, sir.
understand that. So many things are there in the management of warehouses. So you have
Yes,
explained to all very neatly. So
sir.
thank
And
you
one
very
more
much.
thing, this warehouse and e-commerce business is booming like anything. It's
Yes,
going
yes,
to be the next game changer in the
yes,
industries.
yes,
So
yes, yes.
even
So
when
everybody, so online buying is periodically increasing. Every day it is increasing.
yes, sir.
From food to everything now become online. I think people will select in the home itself and they will buy.
Yes, sir.
So warehouse is an inevitable one. So management, part of that is excellent. So thank you very
Yes.
much. So all the best.
Thank
Thank
you,
you very
sir.
much for
Thank you.
sparing your
Thanks,
valuable time.
sir.
So
Thanks for the opportunity, sir.
wait here. Then our honor secretary will speak.
Yes, sir.
Okay, so Arun sir, you can ask the members any
Yes, sir.
clarification.
Yes, sir. Yes, sir. Yes, sir. Thank you, sir. Thank you for your presentation on the inventory management. And I would like to invite Dr. Satish Kumar, Honorary Secretary, Salem Local Center, to propose. Oh, thanks. Yes, sir.
Good evening to everyone.
Yes, sir.
It's my pleasure to on 128 and 120 for them local. To thank
Sir, voice not clear, sir.
for his support.
Satish Kumar, sir, voice not clear.
Yet,
Voice not clear,
one
sir.
minute, sir. Sir, is it audible now?
Yes, sir. Yes, sir. Go ahead.
Now it's clear, sir. Yes, sir.
Yes, sir. I cover Chairman Engineer Loganathan. And also, I'm very happy to thank today's speakers from the Polytechnic, who very presented about Industry 4.0 automation, the need of the topic. Thank you very much, madam. I also very happy to thank the chief guest and keynote speaker of 129th lecture by Engineer P. Karthikeyan, National Manager from Ashok Leyland Shore Unit. Thank you very much, sir, for your wonderful presentation about inventory management. I thank Engineer INR, sir, for having arranged this and conducting these two events today. And happy to note recent days, our stock is always two guest speakers. Dhamaka happening. Thank you, the engineer stock team, Dr. Tangraj sir, Dr. Domani madam, engineer INR sir, Armugam sir, Dr. Kumar sir, and Sendil Kumar sir, the entire engineering talk team. And also, I'm very happy to thank all the senior committee members, committee members, all my dear faculty members and friends, and all participants. I'm happy to thank every one of you. Thank you for all your support in organizing our engineers talk lecture series. Thank you all. Thank you.
Thank you, Honorary Secretary Dr. Satish Kumar sir.
Thank you, sir.
Special thanks to Engineer INR, Engineer Talk team member, for organizing two excellent speakers today. Really, we enjoyed all basically they have covered the topic and made them understand what they are talking. So really, we enjoyed the talk of the Engineer Kavita and Engineer Karthikeyan. So thank you all for being with us. Thank you.
Thank you, sir. Thank you.